Thank you viewers for joining to this lesson. Our topic today is area of part of a circle, and here you're supposed to know about the circle, the components of a circle, and the area attached to these components. So we shall start with the circle, and under the circle we are going to learn the following: isosceles triangles in circles, right angle in a semicircle, tangent line to a circle, diameter symmetry in a circle. We also need to look at the circumference of a circle, the length of an arc of a circle, and area of a circle, and finally area of a sector of a circle before you look at the summary of the circle chapter. And so we shall start with isosceles triangles in a circle, and we have it that when two radii are drawn to the ends of a circle, an isosceles triangle is formed. Now we have a circle with a circle center C and a point on the circumference of this circle. The points are 2, A and B, and now A and B form a chord. When you join the 2 points, you get a chord, and so you join B to the center so that you get the line BC. You again join A to the center so that you get a line AC. And we know that AC and BC are the radii we are talking about of this circle. They are the radius to this circle. And so you know that the base angles of isosceles triangles are equal. So CAB will be x degrees and CBA x degrees. They are the two base angles of isosceles triangle ACB formed. Now let's look at some of the properties of isosceles triangles. So isosceles triangles have 2 of its length equal, 2 of its angles equal, and so angles in any triangle add up to 180 degrees. So the sum of angles in any given triangle add up to 180 degrees. So these are some of the properties that are going to guide us as we try to navigate to the circle and the isosceles triangles found in the circle. So a question: find the angle x degrees in the figure below. Center C, a circle center C, and 2 points on the circumference of this circle, A and B. You join A to B, you get a chord, and the angle CAB is x degrees. That is, we want to find the value of that given angle. And so we are going to start by finding the angle at the center of this circle, so that we find the angle, the inner angle of the isosceles triangle inside the circle. So because sum of angles at a point is 360 degrees, so and our solution, the angle at C is equal to 360 minus 280, and that will give us 80 degrees. From there, since the triangle is isosceles, then we have that CAB is x degrees and CBA x degrees. So that means, and also we have that the sum of angles in a in any given triangle is 180 degrees. And so we'll have that x degrees plus x degrees plus 80 degrees is equal to 180 degrees. And so that will mean 2x degrees plus 80 degrees will give us 180 degrees. And so we want to find the value of x because that is what we've been asked from the question. So the value of x is 50 degrees. That is the solution of that angle. Now, our objective number 2, semicircle angle. So we want to, it is a bit of a geometry. The following tools, we are going to use the following tools to be able to illustrate on the semicircle, the angle of a semicircle. So number 1 is a protractor, number 2 is a pencil, number 3 is a ruler. And using your pencil, trace round the protractor so that you have semicircle. Number 2, make the center of the semicircle as below. So you should have something like this. And then mark 3 points outside the circle. So the first point is there, second and third. Then number 2, on the circumference, you also mark 3 points. My first point is there, second and third. Then number 3, inside the circle. So inside the circle, 1 is there, another one, and finally that. So with that, for each of the points, form a triangle by drawing a line from each end of the diameter to the point. Measure the angle at the various points. So that is what we want to do so that we come up with the various triangles. So from the ends of the diameter to a point outside, we form a triangle. Another one, ends of the diameter to a point on the circumference, and end of the diameter to a point inside. You form another triangle there. So log your result in a table. So whatever you find in terms of, after measuring these angles, then you key in your answers in the table below. So you find out that outside, let's start with the circumference. Then you measure a point on the circumference, that the first angle you get, and then you measure the second one, you measure the third, you'll be able to get 90 degrees. So that means that the diameter of a circle subtends an angle of 90 degrees to the circumference of that circle. Again, it also means that the semicircle subtends an angle of 90 degrees to the circumference of the circle. Well, now outside, if you do outside, you measure the angle found outside, then you will get it is less than 90 degrees. The angle that from a triangle inside, it will give you a value greater than 90 degrees. So our objective number 3, tangent line. We are going to start with the definition of a tangent. And a tangent line is a line that touches a circle at only one point on the circumference of a a circle. Now, which of the following lines are tangent to the circle? So this is a question that you can answer, but we're going to answer it together. So the radius of the circle that touches the tangent line is called the point of contact radius. As you can see from the question that we just asked, which of the lines are tangent to the circles? Probably it is the yellow line and the purple line, because they are the one touching the point, touching the circumference of the circle at a certain point, and probably 1 point. And now, as you can see, the yellow line, it is a tangent to the circle at a point dotted, and the purple line, it is a tangent to this circle at the dotted point. Now, from the center of this circle, that is dotted red, to the line, to the tangent yellow line, you form a radius, and again from the same center to the purple line you form a radius. Now, special property, the point of contact radius is always perpendicular. That means right angled to the tangent line, and that has been illustrated in the diagram shown there. So this means that the radius is perpendicular to the tangent. Radius of a circle is perpendicular to the tangent at the point of contact. At the point of contact of the tangent to the circle. Let's have a question. Find the length of the tangent line between A and B. The length of the tangent line between A and B. From the diagram below, we have the center of the circle is C. A point on the circumference A that gives us the tangent to the circle at point A, and a point on the tangent line B. So we can form a right angle triangle because we have that the radius is perpendicular to the tangent. Then we are going to extract out our right angle triangle so that we find the length of the tangent line between A and B. So solution, right angled at A, since AC is the radius at the point of contact with the tangent. So by using the Pythagoras theorem, then we have that A squared plus B squared equal to C squared. And so substituting into the formula, we have 8 squared, A squared plus 8 squared equal to 10 squared. And now we have A squared equal to 10 squared minus 8 squared. So the value of A in this case is square root of 36, which is 6 units. That is the length of the tangent line between A and B. Okay, in this diagram, we have the center O and a chord AB. Then the diameter, of course, we are now looking at the diameter symmetry, and we want to see the relationship between the diameter of a circle and this chord AB. So we have it that a line drawn through the center of a circle, through the midpoint of a chord, will always cut the chord at right angles. So we have a chord AB, and we have a line drawn through the center of a circle, through the midpoint of a chord. Midpoint of this chord is the center line of the length AB. And now it will cut through the chord at right angles as shown below. Number 2, a line drawn through the center of a circle at right angles to a chord will always bisect that chord. So as you can see, we have the line CD and we have the chord AB. The line is CD is bisecting AB at right angles, and that is illustrated in the diagram. Number 3, a line bisecting a chord at right angles will always pass through the center of a circle. A line that is bisecting a chord passes through the center of a circle. That is also illustrated in the diagram, because we have CD being the diameter, and it is the line that passes through the chord, rather bisecting the chord, and it happens to pass through the center of the circle. Another word, that is the diameter of the circle. Okay, let's now try to use that in a question. Find the length of the chord A and B. The length of the chord A and B from the diagram given below. It is a circle, center O, with a chord AB, and we have the length of the chord not given, because that is what we want, but we have been given the radius to this circle, or rather of this circle, but it is not direct. So to find the radius of this circle, it is 6. So under our solution, radius of the circle will be 4 plus 6, and that will give us 10 units, because OB is the same distance with O. Maybe if we extend this below 4, below the center of the chord, then we can name that point on the circumference maybe D. So OD will be 10 units, equal to OB. Now, since black line bisect AB, you can see the black line from O, the center of the circle, bisect AB and passes through center O. Triangle is right angle, so the triangle there is right angle, so it means it is bisecting the chord at 90 degrees. That is right angle. So by using Pythagoras theorem, we have that a squared plus b squared is equal to c squared. Then, since AB is bisected, the length of AB is, now we substitute into the formula, and we'll be left with the value of A, and that will be the square root of 64, giving us 8 units. So that is just from B to the center point of the chord, center line on the chord, or the midpoint of the chord. From B to the midpoint of this chord is 8 units. But we are told to find the length of the chord A and B. So the distance A and B, meaning we need to multiply 8 by 2 to be able to get the whole length of this chord. So the length AB will be 2 times 8 is equal to 16 units. Our next part of this topic is circumference of a circle, and here we intend to use the formula for calculating the circumference of a circle in tackling some of the questions given. Now, main parts of the circle, we have radius, abbreviated R. We have a diameter, which is 2 times R or 2R. The diameter is abbreviated D, equal to 2R. And again we have the circumference, abbreviated C, which is pi D or 2 pi R. A question: find the circumference of the circle. The circle given here is of radius 4 centimeter, and now we are supposed to find the circumference of this circle. We have it that circumference is equal to pi D. Substitution into that will give us circumference to be pi times 8 units, because the diameter is 2R, so it is 4 times 2. So our circumference will be pi. You can use any of the pi because we have 22/7 and 3.142. So using that, you'll get 25.12 centimeter. Another question: the circumference of a circle is 60 centimeters. Find the length of the diameter and radius. So a diagram is provided here. So we are supposed to find the length of the diameter and the radius given the circumference of the circle drawn below. So we substitute in the formula, circumference is equal to pi D. So we have 60 equal to pi times the diameter, which is not known. So we have that because pi we have it to be 22/7 or 3.142. You can substitute into that and find the diameter to be 60 over pi, and our answer will be in centimeter. So our final diameter will be 19 centimeter. With the diameter we can find the radius because we have diameter equal to 2R. So we divide this figure by 2 and our R will be 19/2. That gives us 9.5 centimeter. Now the length of the arc of a circle. It is another part that we need to cover in this lesson. So we are aiming at finding and using the formula to calculate the length of an arc. So arc length of a circle, we can use the question to be able to find the arc length of the circle. So what is an arc? We want to answer this by using this diagram. An arc is a fraction of the circumference, as you can see, the circumference, and then part of the circumference is shaded yellow and another one is shaded white. So AB is an arc and it is part of the whole circumference. So that gives us a simple definition of an arc to be a fraction of a circumference. Now you can see we have two types of arcs. That is the minor arc, shaded white, and we have major arc, shaded yellow. Now, find the circumference of the circle from the diagram below. The diagram is a circle of radius 10 centimeter, and we need to find the circumference of this. We substitute into the formula, and probably that will get us 62.8 centimeter as the circumference of this circle. Now, another question: find the length of the minor arc XY below. So from the diagram below, the radius of this circle is 6 centimeters. Then we have XY subtend an angle of 45 degrees to the center of this circle. And so we are supposed to find the length of this minor arc XY. And now we have the connection that the arc length, it is because it is a portion of the circumference, and the circumference is the distance all round this circle, and so given by pi d. So we shall have the arc length over the pi d, that is the circumference, equating to the arc angle over the total angle in a circle, that is at a point 360 degrees. So that will be arc angle over 360 degrees. Now with that, we have the formula for finding the length of an arc of a circle to be, in simple terms, theta over 360 degrees pi d, or 2 pi r, because that is the circumference. And so in our case here, arc length will be 45 degrees over 360 degrees times pi d, where pi can be 22 over 7 or 3.142, times the diameter, which is 2r, that is 6 times 2. That will give us the arc length of 4.71 centimeter. Another example: find the length of the minor arc AB, and we use the same method. Having known that the radius of this circle is 9 centimeter, and arc AB, that is the minor arc, subtends an angle of 60 degrees to the center of this circle. So we have the length of this arc to be 60 degrees over 360 degrees from the formula, times pi times the diameter, that is 9 times 2, being 18. And the arc length is 9.42 centimeter. Now we have found the length of the minor arc. This time round we want to find the length of the major arc, that is PQ. And we are going to use the formula to be able to find this concept of the major arc. The same formula works in the same way for minor arc, and the major arc. And so if we have PQ on the minor arc, subtending an angle of 100 degrees to the center of this circle, and angle at a point tells us that the angle at a certain point is equivalent to 360 degrees, sorry. So having 100 degrees, then it means the remaining angle is 260 degrees. 260 degrees. So that is what forms the major arc. So if you use 100, then you will be answering, you will be finding the length of the minor arc. So you have to use the major angle, or the angle attached to the major arc. So that arc will be, substituting into the formula, 260 over 360 degrees times pi times 10 times 2, meaning it is 20. And so the arc length will be 45.38 centimeters. Area of a circle, as we near to finish this lesson. So we aim to come up with and be able to use the formula for calculating the area of a circle. And in this case, we are going to derive the formula used to find the area of a circle. So if we break the circle into equal sectors and lay them out side by side, we get very close to a rectangle. You can see the diagram is of a circle subdivided into 8 sectors. So we are going to break the sectors and lay them side by side. So total sectors were 8, and so you realize that they are forming a rectangle. Now, having that arrangement, now if we cut the sectors thinner and thinner, then we get closer and closer to a rectangle. Hence, we can represent the area of a circle by a rectangle. So we are going to reduce these sectors thinner and thinner, and that is what we get. And then the width of this rectangle is r, that is the radius of the sectors. Then the length will be pi r. And now we want to find the area of this rectangle. Having known that area of a rectangle is equal to length times width, or length times breadth, and we get pi r times r, that will give us pi r square. So, but the area inside this rectangle is also the area of the circle. So area of the circle equal to pi r squared. Hence the formula is derived. Now let's use that formula to answer some of the questions. Find the area of the circle, and the circle is of radius 4 centimeter. So with the formula pi r squared, we substitute pi. You can use any, so pi times 4 squared, you'll get area to be 50.26 square centimeters. Number 2, the diameter of a circle is 60 centimeters. Find the area of the circle. So we have the formula pi r squared for the area, and the radius is d over 2, or the diameter divided by 2, you get radius, and we will have 30 centimeters. Substituting that into the formula for the area of a circle, you get area is equal to 28,827.43, or 2827.43 square centimeters. The area of a circle is 12.64 square centimeters. Find its radius. So you realize that this question can be changed into different aspects depending on what they are asking. They can ask any other part of the circle about the radius, diameter, and even the area. So in this question, they want us to find the radius of this circle with the area given as 12.64 square centimeters. So of course, we have our formula, area is equal to pi r squared. Then we substitute so that we are left with r as the subject of the formula. So r squared is equal to 4 centimeter. To remain with r, we square root both sides, and so radius of this circle is 2 centimeter. Our last part is sector area over circle, the area of a sector of this circle. So we intend to find and use the formula for calculating the sector of a circle. Now, this is our circle with the minor sector AB, the minor arc AB, and the major arc on the line yellow. So the minor arc AB subtends an angle theta to the center of this circle to give us a minor sector. And so we also have a major sector, and from that a diagram, then we can find the area of a circle so that we get used to the formula as we prepare to get to the area of a sector. So in this question, find the area of a circle. The radius is 10 centimeter. The area will be 314 centimeter square. And now our next question will be on the minor sector, and so find the area of the minor sector XY below from the diagram below. It is a circle of radius 6 centimeter, and the minor arc XY subtends an angle of 45 degrees to the center of this circle, and we are supposed to find the area of the minor sector. We have a connection. The area of a sector, we have the circumference, and so we shall find the whole area of the, remember a sector is just a portion in a circle, so we need to find the fraction, that is the area of the sector over the whole area of the circle. So we have area sector or area of a sector over the area of a circle, that is pi r squared, equal to the angle of that sector over the total angle in this circle, that is 360 degrees. So in simple terms, we have it that the formula for finding the area of a sector, be it minor or major, it is theta over 360 degrees pi r squared. So answering the question, area of a sector is 45 over 360 times pi times radius squared, that is 6 squared. So that will give us 14.14 square centimeters. The second question, find the area of the minor sector AB. So we use the same approach, substituting into the formula, whereby we have that theta over 360 degrees pi r squared So our theta, which is the angle subtended by the minor arc AB, 60 degrees over 360 times pi times 9 square. The area of this sector is 42.41 square centimeters, and the sector is the part shaded green. Now we want to find the other part of the circle, that is the major sector, subtended by the angle 360 minus 100 degrees, that is 260 degrees. And so, substituting into the formula, we have 260 over 360 times pi times 10 square, and we have the area of the sector to be 226.89 square centimeters. Now, let's have, as we finish, a summary of the circle chapter, or rather the circle topic. We have, it starts with a circle, then the component of this circle, we have one is the radius, given as a half of diameter. Then we have the diameter, given as 2 times r, or 2 times radius. We have the circumference of a circle, given by the formula pi d, or pi times diameter. Another part from the circumference, we have the arc length. Arc length, or the length of an arc, given by pi over 360 degrees. No, theta over 360 degrees, sorry. We have theta, that is the angle subtended at the center by the minor arc or major arc. So we have it as theta over 360 degrees times 2 pi r or pi d. So from there, we have the area of a circle, given as pi r squared, and we have derived that. Another thing, we have the area of a sector, which we have given out in simple terms as theta over 360 degrees pi r squared. Another thing, and now we have the information on the diameter symmetry, that is the diameter and the chord. So line that bisect a chord split the chord into 2 equal halves, that is 1, 2, make right angle with the chord, and 3, passes through center of the circle. Another part of the circle summarized is the semicircle, and the diameter subtends an angle of 90 degrees in the circumference of the circle. Also, we can also say that semicircle subtends an angle of 90 degrees to the circumference of the circle. So that is summarized as below. And then if you extract this angle, the right angle, of course, right angle triangle, then you can use Pythagoras theorem or SOHCAHTOA to find some of its sides or the angles in that triangle. We also have the tangent that touches the circle. So we say that tangent touches circles at one point and make angles 90 degrees with the point of contact radius. So radius is perpendicular to the tangent, and the point of contact is at right angle. That is 90 degrees. So that marks the end of this lesson. Don't